Here's a practice SAT question. It allows for us to use a calculator, and this problem asks us to decide which of the following options is not a solution to the inequality. So when you have an inequality, a big chunk of the number line is typically going to satisfy that inequality. And so here we've got, I guess, three of these four numbers are going to satisfy the inequality, and one of them is not. Now, because you have options presented to you here, it's definitely fine to use guess and check. Plug -1 in place of this x in place of this x, see if it's true or false. Do that with the rest of these values, and you're going to have your result. So the good news is it's a multiple choice test. The bad news is a multiple choice test. So take advantage of it in cases like this, but be cautious because there are going to be some options there that are probably pretty good distractors. What I chose to do is I just chose to solve the inequality. So you solve an inequality just like you solve an equation. You want to isolate the variable. The one thing that you have to remember about solving an inequality, though, is if you ever multiply or divide both sides of the inequality by a negative, you're going to have to flip that inequality symbol. So keeping that in mind, what I chose to do to get all of my x's onto the same side, I chose to subtract 3x from both sides of the inequality, because if I do 4x minus 3x, I keep a positive number in front of x. If I ever ended up with a negative number in front of the x, and I'd have to multiply or divide both sides of the inequality by that negative, I'm going to have to flip that symbol at the point in time when I do that step. I find every way to avoid having to do that. I don't want to accidentally forget to do that. So I'm always going to solve inequalities like this in a way that allows me to keep the coefficient of x positive whenever I possibly can. So let's see, I guess we got 1x minus 3 over here. I guess we'll want to isolate this x, so I'm going to add 3 to both sides. I'm leaving it with a -2. Uh, I have 1x. I guess I could divide both sides by +1, but when the coefficient of x is 1, x is already isolated, so nothing changes on this side. I did not ever have to divide both sides by a negative or multiply both sides by a negative, so I'm not in need of ever having to flip that symbol. So what I did real fast is I tried to show where the section of the number line is that's going to satisfy the inequality. So I put a closed circle, right? I'm allowed to be equal to with this solution. So I put a closed circle at -2, and I just thought, okay, where are the numbers that are going to make this true? Is -3, if I put that in for x, is -2 greater than or equal to -3? Yeah, it is. Same thing with -4, -5, -5 million. So this stretch of the number line that you see I kind of shaded in there, that's going to be the stretch of the number line that satisfies the inequality. -2 does satisfy it, right? Because -2 is greater than or equal to -2. But -1, this guy right here, -1 is the one value that's not in that shaded section of the number line. That is the one value that is not going to satisfy the inequality. So we took the direct approach here. Like I mentioned at the beginning of this discussion, though, you could have also used guess and check since you had the answers provided to you as those multiple choice options.